Hello everyone, welcome back to LFI Educates. Today we are going to discuss about accuracy and precision of measurements. First of all, let us discuss about accuracy. Accuracy of a measured value, or we can say accuracy of a measurement, is a measure of how close the measured value is with the true value. Suppose your true value of a certain physical quantity, say acceleration due to gravity of the earth, this is 9.8 meter per second square, and you measured your measured value of g, suppose it is 9.7 meter per second square. This value will tell us how accurately you have measured. One person has measured the acceleration due to gravity as 9.7. Say another person has measured as 9.5 meter per second square. Then if you compare these two values, then you will say that this first person, his accuracy is much more because it is near to the true value than the second person. That's what we call it as accuracy. And then the second term, that is precision. Precision tells us to what resolution or limit the value is measured. It basically depends upon the instrument. If the instrument least count, when we say least count, that is the least possible measured value with a particular instrument. Suppose when we take our ordinary scale, the ordinary scale starts from 0, 1, 2, 3 and so on. They are in centimeters. Like you will have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is a 10th line. So one marking from 0 to this point, it is 0.1 centimeter. So this is the least count of an ordinary scale. So precision, you cannot expect in an ordinary scale to get a value closer like this 0.001 centimeter. Like this you cannot expect to get. That much close you cannot come. Your minimum value that you can measure with an ordinary scale is only 0.1 centimeter, or we call it as 1 millimeter. So this is your least count. Beyond that value we cannot measure. Smaller than that we cannot make it. So precision even gives us which instrument is more precise than the other. When we talk about vernier caliper, the least count is 0.01 centimeter. When you talk about screw gauge, the least count is 0.001 centimeter. When you talk about an ordinary scale, it is 0.1 centimeter. This is your scale. This is your vernier calipers. And this is your screw gauge. Now these values will tell you that screw gauge is more precise than vernier caliper. Again, vernier caliper is more precise than scale. So in scale you cannot expect to get like this value. In vernier caliper you cannot expect to get like these smaller values. So this tells us about the limit of resolution, we say. Limit of resolution that can be given by a particular instrument. The more precise the instrument is, the more limit of resolution you will get it. More accurately you will get the values. Now let us discuss about errors in measurement. There are two types of errors in measurement system. The first one is your systematic error. Under systematic error, you have these three. One is called the instrumental error. The second one, you have imperfection. In experimental technique. And the third one, we call it as personal error. Personal error. And then the other one, systematic, and the other one is your random errors. So it is classified like this: errors, systematic error, and random errors. Under random errors, you even have least count error. Like this it goes. First of all, let us see about the systematic error. The first, instrumental error here. Instrumental error is maybe due to imperfection in making the instrument, or due to wear and tear of the instrument, or due to continuous use of the instrument. The screws, nuts may go here and there, left and right. So this error may occur because of the instrument itself is not in a proper shape. The second error, that is imperfection in experimental technique. Suppose a person does not know how to carry on the experiment, then this type of errors will occur. There is imperfection in experimental observation or technique. As an example, suppose you have a thermometer with you and then you want to check your body temperature. You are keeping under the armpit. After a few minutes, if you look the thermometer scale, it has given some measurement that you are taking it as your body temperature, but actually your body temperature inside it is much higher than outside the body. So that is also one of the imperfection in measuring the temperature of the body that will come under this. The third one, this is your personal error. The apparatus is given to you, then you don't know how to set up properly, unable to set up properly, then error may occur, and that error we call it as personal error. Or while doing with friends, somebody might have pushed you, pulled you while doing the experiment, then also error may occur. That error will come under personal error. Then when you talk about random errors are irregular, it is unnatural. Like suppose you are doing an electrical experiment, while taking the readings of ammeter, voltmeter, suddenly the voltage went high. Then high fluctuation will be there. Then suddenly the temperature, suddenly the current potential difference values will change or increase, and then it will fall down again quickly. Then like that also you may come across while doing the experiments, and that type of error we call it as random errors. And this least count error also comes under random errors. Suppose, as I said earlier, that an instrument cannot give you a precise value. Suppose you want 7.001 or 007 centimeter, and you are using a vernier calipers. There it will give you say 7.08 centimeter. Now this third value you cannot find out because the least count of the instrument is only after decimal 2 digits here. You want to get the third digit, then you cannot get that value, and that will lead to least count error. Now let me clarify you regarding these two terms, even though it is not from the book. One is mistake and one is error. Error is likely to happen. Every human being will make errors. That is natural. We human beings are not perfect. But you cannot make mistake. Here these two words, mistake and error, in physics, it has a vast difference. Mistake, when you say, suppose the true value of a particular quantity, physical quantity is say 9.7, and when you are doing the experiment 9.7 centimeters say, and when doing the experiment you got here 200 centimeter. After doing the experiment you got the value as 200 centimeter, then this is purely a mistake. This one we call it as a mistake. But when we talk about error, if the true value is 9.7, if you are getting it as 10 centimeter, or you are getting it as 9.8 centimeter, or you are getting it as 9.6 centimeter, then it is almost close to 9.7. It's almost close to 9.7. It is manageable, or we can say that a slight error has occurred. So there is a difference between these two, mistake and error. Vast, big errors we call it as mistake, and small errors or small differences in a value we call it as error. Now let us discuss about this absolute error, mean absolute error, relative error and percentage error. Here one question I have written here, as it is purely mathematical. In an experiment, refractive index of glass was observed to be 1.45, 1.56. Let us, some values are given, the observed values. Let us choose the letter U here. You can choose any letter you like. You can use mu also for refractive index. I am choosing U. U1, suppose it is 1.45. These are the observed values during an experiment. U2 is 1.56. U3 is 1.54. U4 is 1.44, U5 is 1.54, and U6, 6 observations are taken, 1.53 suppose. So first what we'll have to do is, you'll have to find out the mean value of refractive index, and that is what is asked here, mean value of refractive index. As you all know, mean value of refractive index, mean we write it as bar here. Bar indicates mean. It is the sum of observation U1 plus U2 plus U3 plus up to U6 divided by number of observation is 6. So you will add up all these values and then you will divide by 6. You can even write down here, or directly you can add it up. Plus 1.54 plus 1.44 plus 1.54 plus 1.53. You divide it by 6. And you add it 5, 6, 11, 15, 19, 23, 26. 2 in hand, 2, 4, 6, 5, 11, 16, 20, 25, 5 is 30. 0, 3 in hand, 3, 4, 5, 6, 7, 8, 9. Divided by 6. 9.06, you are going to divide by 6. 6 ones are 6. 3, then bring 0. 6 fives are 30. And 6, 6 ones are 6. 1.551. This is also known as true value. True value. Like this you will get it first. After that, the second one, to find out the mean absolute error, first of all you have to find out the absolute error in each observation. Second one to do, first you will find out the absolute error in each observation. We write it as delta here, delta U I'll write. Delta U means absolute error. This is your formula, absolute value of true value minus the observed value. This one, these are your observed values, U1, U2, U3. The purpose of taking the absolute value is that whether you get negative or positive in the term, you have to take only the positive value. So let us see one by one. Delta U1, to find out, true value is 1.51 minus observed value for U1 is 1.45. 1.45. So it will give you 11 minus 5 is 6, 0.0. So it will become 0.06. Then delta U2 is 1.51 minus the second value U2 is 1.56. So here you can see very clearly that answer will come in minus 0.05. But 6 minus 1 is 5. But you cannot take the negative value, you have to take the positive one, 0.05. Then delta U3 you will find out 1.51 minus third value is some 1.54. Here also you will be getting 0.03 with negative sign. We will take the positive value. Delta U4 1.51 minus 1.44. This time you will get positive value 0.07. It will remain positive only. Then next you will get delta U5 1.51 minus 1.54. So here also you will get a negative value minus 0.03. It will be minus, change it to plus 0.03. Delta U6 1.51 minus 1.5. It is 3. So it is minus 0.02. Then you will get 0.02. After doing this, then only you can find out the mean absolute error. The mean absolute error will be will write delta U bar. Bar indicates mean. Then it will be delta U1 plus delta U2 plus delta U3 plus it will go up to delta U6 divided by number of observation is 6. Then we'll add up all the values that you found out. 0.06, 0.06 plus 0.05 plus 0.03 plus 0.07 plus 0.03 plus 0.02 will divide by 6. Then you will get, add it up, 6 plus 5, 11, 11 plus 3, 14, 14 plus 7, 21, 21 plus 3, 24, 24 plus 2 is 26, divided by 6. 0.26 we are dividing by 6, 0, here 0, decimal, decimal, 2 cannot divide 0, 0, 6, or you can write 6 4s are 24, 2 0 6 3s are 18, 2 0 6 3 3 3 will go on. You can take after decimal 2 digit 0 4 you can take. This will be your mean absolute error. After you find out the mean absolute error, the next thing we'll have to do is the fractional error to find out, which we call it as relative error as well. Now to find out the third one is fractional error. Or relative error, we use the symbol del, that is the mean absolute error delta U bar divided by the true value, that is your mean. Your mean absolute error is 0.04 divided by your mean value was 1.51. Now after decimal you have two digits, so you just remove it, 151, then divide 4. If you divide by 1510 decimal 00, this 2 times will come in 3 times. Let us see, 3 ones are 3, 3 5 are 15, 5 1 in hand, 3 ones 3, 4. So it is bigger. I'll take 2 times. 2 ones are 2, 10 0 1 in hand, 2 3, 98. Then 0 you can take it. 1 5 1 6 times, 30 6 7 8 9. Yes, 6 times it will come 906. You can write this as 0.026. After finding out the fractional error, this is your fractional error. The next step you are going to do is your percentage error. Now percentage error, to do, just simply this fractional error will multiply by 100%. The third one, fourth one, that is your percentage error. Percentage error, we can write this as delta U bar divided by mean into 100%. This is a fractional error multiplied by 100%. This is 0.026 divided by, this one overall is 0.026 multiplied by 100%. 26 ones are 26, then 2 zeros you have, after decimal 3 digit. So ultimately you can write this as 2.6%. This is your percentage error. Now the next one, express the result in terms of mean absolute error and percentage error. So how to write down the result ultimately, I'll show you here. To express the result in terms of mean absolute error, you write U is equal to, we have chosen the letter U for refractive index. The true value, the mean value is 1.51. Plus or minus you will put it, and then the mean absolute error value you write down 0.04. Then result in terms of the next one, percentage error. You can represent like this: U is equal to 1.51, your mean value, this is a true value, plus or minus in terms of percentage, it is 2.6%. 2.6%. And if they ask you to write down the result in terms of fractional error, then also you write down 1.51 plus or minus 0.026. This is the way of representing the result at the end, ultimately the correct value to say. Now let us discuss about combination of errors. The first one I have written here, error of a sum or difference. When you are adding up or subtracting it, how to deal with errors. Suppose two physical quantities A and B I have chosen. Their values are given to you like A plus, the true value, plus or minus the absolute error delta A. As an example, this is the error part. And then the second physical quantity, your true value is B itself, plus or minus delta B. These are the absolute errors, delta A and delta B. Now when I add A and B, or when I subtract A and B, then the error part, the absolute error, let us say it as delta Z, that will be the sum of the absolute errors of A and B. Whether you do addition or you do subtraction, the error part, I'm talking about the error part, it will be the sum of the two absolute errors. And the front part, that the true value A and B, if it is sum, you will add it. If it is difference, then you have to subtract it. But the error part, you have to add them, be it sum or be it difference. So here is one question. If L1 is given as 10.0 plus or minus 0.1 and L2 is given as 9.0 into plus or minus 0.2 centimeter, find their sum, difference and percentage error in each case. Now first of all, we'll concentrate here how to find out their sum and difference. As I said here, the error how to deal. Let us do first like this. Sum to do, these two parts will edit. The first part we are going to edit 10.0 plus 9.0. But the second part, that is plus or minus, as I said, when you are doing sum also, the second part, this delta A, this is delta B, you will have to add them. 0.1 plus 0.2. Everything will be in centimeter. So this one will come out as 19 plus or minus 0.3 centimeter. This is the way to be done. The second part, the difference. When you do the difference, the first part, the true values, you will subtract them. 10.0 minus 9.0 plus or minus the error part. As I said to you, you need to add it. Whether it is you are doing sum or you are doing difference, the error part needs to be added up. So the error, you add it up like this: 0.1 plus 0.2. Everything will be in centimeter. This is 1 or 1.0 plus or minus 0.3 centimeter. This is the way to be done, addition and subtraction. Now when you talk about percentage error to find out, you already know the formula. Percentage error in each case. Percentage error in sum of sum, it will be the absolute error. The sum's absolute error, it is 0.3 divided by the true value. The true value in sum is 19. You multiply with 100%. Now this one is 3.3 to 100 is 30 divided by 19. Then you can divide it. 30 divided by 19. 1 time is 19. 11. 0. Then decimal will come. 19 7 times. 13. 6 times. 5 times. 5 times you can take it, 45, 95, so you can write this 1.5%. Like that, percentage error in difference. Percentage error in difference or of difference. You write down the relative error, that is your 0.3 divided by the true value, that is 1 into 100%. This will give you around 30% in difference. Now let us see the second one, that is your error of a product or a quotient. When you are doing a product, multiplying, or you're dividing it, and suppose your value is like this, z is equal to a into b, or z is equal to a divided by b. This is for product, this is for quotient. Here what you have to do is, you have to find out the relative error. Now relative error, to find out, you will do it like this: delta z by z is equal to delta a by a plus delta b by b. Be it multiplication or division. The error part, the relative error, you will do it in the same way. It is for both, it's applicable for both product as well as quotient. The resistance of a metallic conductor is given by R is equal to V by I, where V is potential difference and I is current. Where V, the potential difference, is given to you, and the current in the circuit is also given. What is the value of resistance? Now generally you know that R is equal to V by I. The formula is there with you, so you can first find out the true value. When you find out the true value, it will be 8 divided by, you will take only the true value from both the cases, 8 divided by 4, it will give you 2, and resistance unit is ohm. First of all, you will do this part, and after that you will use your formula for relative error. That is delta R by R is equal to delta V by V plus delta I by I. Is divided by, but you will do plus here and then write down relative form. Delta V is 0.5 divided by V, it is 8, plus delta I, it is 0.2 divided by I, it is 4. So we will calculate it first. Then 5.5 divided by 8 point, cannot divide, you put 0. Then if you put here 0, 8 6 are 48, 2 0, 8 1s are 8, you can neglect it. 0.06 plus 0.2 divided by 4, point, cannot divide 0, 0 you will put it, 4 5s are 20, so it will come out as 11 1 in hand, 1.0. Like this you will find out the relative error. After you find out the relative error, then here in the question, what is the value of resistance with its percentage error they are asking, not with relative error. If it is with relative error, then your true value of resistance plus or minus this value 0.11 will give you the value of resistance. Therefore, you can write the value of resistance R is equal to your true value, that is 2 ohm, 2 ohm plus or minus 0.11, or you can write like this, 2 plus or minus 0.11 ohm. This is your value of resistance in terms of relative error. But if they ask you in terms of percentage error, that this value you have to multiply by 100%. Percentage error you can find like this. Percentage error is equal to delta R by R multiply with 100, then it will become percent, 0.11 into 100%, 1100 after decimal 2 digit, so it is 11%. So in terms of percentage error, the value of resistance will be 2, this is the true value, 2 plus or minus 11%. The value of resistance in terms of percentage error, it will be 2 plus or minus 11 percent, 2 ohm plus or minus 11%. Like this you can measure the resistance with its percentage error. Sometimes it may come directly like this to find out. In that case, then multiply by 100% and then add or subtract with this true value. But if they ask you in terms of resistance, in terms of relative error, then this will be your answer. Now let us see the third variety, that is error in case of a measured quantity raised to a power. Suppose a physical quantity is given to you, z is equal to a to the power n, b to the power n, like this. It may be multiplication or it may be division as well, but they have powers in them. Now in this case, what you do, the measured relative error will be delta z by z is equal to this power, just you have to bring towards your left, n times multiply delta a divided by a plus delta, again here also power is n, so we'll bring down n, delta b divided by b, and so on. So this is the way to find out the relative error in case of a physical quantity raised to a power. Here also one small numerical we'll have to do and see. You are asked to find out the relative error in z. If z is equal to a to the power 4, z is equal to a to the power 4, b to the power 1 by 3 divided by c d to the power 3 by 2. Like this, if you get a mixture of division multiplication, this way you'll have to do the relative error in z. Delta z by z, you'll write it is equal to, power is 4, so you'll write 4 delta a, the relative error in a, plus you'll put, don't put multiply or minus, power is 1 by 3 delta b divided by b, the relative error in b, divided by, still you'll write plus, power is 1, so nothing, so relative error in c, again plus, multiply also plus, division also plus, only you'll write power is 3 by 2 into delta d by d, the relative error in d. So this will give you the overall relative error in z. Thank you and have a nice day. Stay tuned with LFI Educates.